Imagine a world where the sky is a brilliant, beautiful blue. It might remind you of a perfect summer day here on Earth. You might feel tempted to step outside and feel the breeze on your skin, but on this world, that would be the last thing you ever do. The weather here is not made of gentle water droplets or soft, fluffy snow. Instead, the storm clouds gather to unleash something straight out of a science fiction nightmare. On this alien world, it rains glass. Not just any glass, but molten sideways glass flying through the air at speeds that would make a bullet seem slow. This isn't a metaphor, it's a literal, physical reality happening on a planet far, far away. This idea challenges everything we know about weather. We think of rain as life-giving, something that nourishes our planet and allows plants to grow. We watch storms from our windows, feeling safe and cozy inside. But the universe is vast, and it doesn't play by our rules. It has planets with conditions so extreme, they defy our earthly imagination. The concept of a glass storm forces us to expand our understanding of what a planet can be. It reminds us that the cosmos is filled with wonders and terrors beyond our wildest dreams. This isn't just a story, it's a window into the extreme and violent nature of other solar systems, a place where the very elements behave in ways we can barely comprehend. So how is such a thing even possible? How can a planet produce rain made of solid shards of glass? The answer lies in the unique and brutal chemistry of its atmosphere, combined with temperatures that would instantly vaporize any life as we know it. The planet with this mind-bending weather has a name that sounds a bit like a license plate, HD 189733b. It's not a catchy name like Mars or Venus, but astronomers often catalog objects that way. This exoplanet, a world orbiting a star beyond our sun, is about 63 light-years away. That sounds close, but a light-year is the distance light travels in 1 year, nearly 6 trillion miles. So a trip would take our fastest spacecraft tens of thousands of years. It sits in the constellation Vulpecula, Latin for the little fox. HD 189733b is what we call a hot Jupiter, a gas giant similar in size to Jupiter but orbiting extremely close to its star. Think Mercury, the closest planet to our sun. Mercury completes an orbit in 88 days. HD 189733b makes Mercury look slow. It orbits its star in just 2.2 Earth days. That brutal proximity causes its extreme conditions. The planet is tidally locked. The same side always faces its star, like our moon faces Earth. The recipe for glass rain sounds simple, but it requires some very extreme cosmic ingredients. The key ingredient is silicon, one of the most common elements in the universe. Here on Earth, we find silicon in sand quartz. When we melt sand at very high temperatures, we get molten glass. Now imagine a planet where the atmosphere is so hot that silicon-based particles, silicates, are vaporized. They turn into a gas, a silicate vapor, floating in the planet's upper atmosphere. This is the first step in creating the most dangerous rain imaginable. On the scorching day side of HD 189733b, temperatures can soar above 1,800 degrees Fahrenheit, about 1,000 degrees Celsius. At these temperatures, silicate particles can't stay solid, can't stay liquid. They exist as a hot, invisible vapor mixed into the atmosphere. Powerful winds carry this silicate vapor from the hot day side to the slightly cooler night side. The night side is still extremely hot by Earth standards, but just cool enough for the next step. As the silicate vapor reaches the night side, it begins to cool. Like water vapor condensing into droplets on Earth, silicate vapor condenses into tiny droplets of molten glass, a cloud made of lava. The droplets clump together, growing larger and heavier. Vast swirling clouds of hot liquid glass form. Eventually the droplets get too heavy and begin to fall. The glass rain begins. This isn't a gentle shower. Let's tune in for the daily weather forecast on HD 189733b. Good morning, residents of the day side. Expect another beautiful, clear day, temperatures holding steady at a blistering 1,800 degrees F. The skies will be a lovely shade of cobalt blue, but don't be fooled. Main story: extreme wind advisory across the entire planet. Sustained winds blowing from east to west around 5,400 miles per hour. That's more than 7 times the speed of sound. We advise against any and all outdoor activities these winds carry superheated silicate particles. Moving to the terminator line, the boundary between the day side and the night side, this is where the action really picks up. Atmospheric pressure and temperature swing to extremes here. Forecast massive cloud banks of condensing molten glass. Night side residents, expect heavy precipitation. 100% chance of sideways glass rain. Solidifying glass shards traveling at hypersonic speeds exposed surfaces will suffer catastrophic abrasion. Visibility will be near zero. Extended outlook, this pattern is effectively permanent. There is no calm season on HD 189733b. When we think of rain on Earth, we usually picture a gentle, life-sustaining process. Water evaporates from oceans and lakes, rises into the atmosphere, forms clouds, and then falls back down as rain, watering our plants, filling our rivers. It's a closed, delicate cycle that honestly makes life possible. The rain is made of water, H2O, a compound that's essential for every living thing we know. The drops fall vertically, pulled down by gravity at a relatively gentle speed of about 20 miles per hour. We can stand in it, we can drink it, and we celebrate its arrival after a long drought. It's a symbol of renewal and, well, life itself. Now let's contrast that with the rain on HD 189733b. The substance isn't water, it's silicon dioxide. Silicon dioxide, the primary component of glass. The cycle isn't driven by gentle solar heating over a vast ocean, but by the raw, brutal energy of a star on a planet orbiting far too close. Beyond the headlining fact of its glass rain, HD 189733b is full of other astonishing details that make it one of the most fascinating exoplanets we've discovered. Let's start with those winds again. We say they travel at 5,400 miles per hour, but it's hard to truly grasp that speed. That is Mach 7, 7 times the speed of sound. If you could somehow survive on this planet, you wouldn't hear the storm coming. The glass shards would hit you and tear you apart long before the sound of the wind ever reached your ears. It is a truly silent and instant form of destruction. Another incredible fact is how we even know all this. We can't see the planet directly. It's too far away and too close to its star. Instead, astronomers use clever techniques. One method is called transit spectroscopy. When the planet passes in front of its star from our point of view, a tiny amount of the star's light filters through the planet's atmosphere. By analyzing the spectrum of that light, scientists can see which chemical elements are present. They detected the signature of sodium, hinting at hot clouds. Later, the telltale signs of silicate particles, the building blocks of glass. One of the most poetic and cruel twists about HD 189733b is its color. When astronomers measured the light reflecting off the planet, they discovered it has a beautiful, deep cobalt blue hue. If you were to see it from a distance, it might look strikingly similar to Earth. Our own planet is called the pale blue dot because of the way our oceans and atmosphere scatter sunlight. You might look at this distant blue world and feel a sense of familiarity, a touch of home. But honestly, this sense of comfort could not be more misplaced. Its beauty is a mask for one of the most hostile environments we've ever found. The reason for Earth's blue color is a phenomenon called Rayleigh scattering. The molecules in our atmosphere, mostly nitrogen, oxygen, are better at scattering short wavelength blue light than long wavelength red light. So when sunlight hits our atmosphere, the blue light is scattered in all directions, making the sky appear blue. But on HD 189733b, the reason for the blue color is far more violent and exotic. You might be asking yourself, why should we care a planet 63 light-years away where it rains glass? We can never go there and its conditions are completely irrelevant to our daily lives. But studying extreme worlds like HD 18973b is absolutely fundamental to our understanding of the universe. These freak planets are not just curiosities, they are natural laboratories that test the limits of physics and chemistry. They show us what is possible under conditions that we could never hope to replicate here on Earth, pushing our scientific models to their breaking points. By studying the atmosphere of a hot Jupiter, we learn more about how all atmospheres work, including our own. The principles of atmospheric circulation, how heat is moved around a planet, are the same everywhere. On HD 18973b, these principles are just turned up to 11. By seeing how an atmosphere behaves under such extreme wind speeds and temperatures, we can refine the computer models we use to predict weather and climate change on Earth. These extreme exoplanets provide us with crucial data points that help us build a more complete picture of planetary science. Furthermore, the search for life beyond Earth requires us to understand the full spectrum of what a planet can be. For a long time, we assumed other solar systems would look a lot like ours, but discoveries like hot Jupiters and glass rain worlds have shattered that assumption. The universe is more diverse and more creative than we ever imagined. By cataloging these strange worlds, we learn to recognize the difference between a planet that is truly habitable and one that is merely pretending, like the beautiful but deadly HD 18973b. It helps us narrow our search and focus our powerful telescopes on the most promising candidates. Ultimately, we study these worlds for the same reason we climb mountains. So we have journeyed to a world of blue beauty and unimaginable violence, a planet where the weather forecast calls for a 100% chance of sideways hypersonic glass storms today and every day. HD 18973b stands as a testament to the wild and unpredictable nature of the cosmos. It forces us to reconsider our quaint, Earth-centric ideas about what constitutes weather: a gentle spring shower, a planet-wide storm of molten glass, two sides of the same cosmic coin governed by the same fundamental laws of physics, just playing out in vastly different arenas. This single, bizarre world opens up a universe of questions. If a planet can rain glass, what other strange forms of precipitation might be out there? Could there be worlds where it rains iron diamonds or even sulfuric acid? The answer, astronomers believe, is yes. We are just at the beginning of our exploration of exoplanets. With every new telescope we launch and every new technique we develop, we are peeling back the layers of the cosmos and finding worlds that are stranger than we ever dared to imagine. If you found this journey to a world of glass rain as mind-blowing as I did, share it with someone to spread the cosmic perspective. And make sure to follow for more stories from our incredible universe. The cosmos awaits. Stay curious, keep asking questions. The answers are out there, waiting among the stars. If you enjoyed this, share, and subscribe for more. There's always more out there to discover. This story is just one chapter of the cosmos. Subscribe to join the journey. We are living in a golden age of cosmic discovery. The story of HD 18973b is just one chapter in the ever-unfolding story of the cosmos. There are countless more to be written. If you love this, hit like, share it with a friend, and subscribe for weekly cosmic stories.